Friends, we have so far discussed extraction of various metals in 8 modules that I have covered so far. I now come to module number 9. You will recall that earlier we have talked about extraction of a very large number of non-ferrous metals from their minerals and ores, whether they were in sulphides, they were as oxides or chlorides, the metals were in minerals, and in ores these minerals were found associated with lots of other things, the unwanted ones we called gang materials. Very often many minerals were mixed together. So, from one ore one could get not only one element, but many other elements. Now, we are coming to discuss ores where metals are not present as minerals, but they are present in elemental form mostly. And we will also discuss recovery of metallic values from metallic scrap that is rejected after the consumer has found the use over certain period of time, and then the consumer has discarded. When we come to metallurgical wastes which are not scrap, that can also be a source of recovery of metallic values, but let me put emphasis on only these two metals which are mostly found in elemental form in nature, and metallic scrap which is also in elemental form. Of course, it may have undergone some weathering, some reoxidation, or it may be there in not exactly in the elemental form, but definitely they are not as minerals. There could be one or two exceptions. For example, silver does form some compounds, but they are very weak compounds, very easily the metals can be recovered from that. That is an exception. So, in this module which is about precious metals and secondary metals, our learning objectives will be to first talk about extraction of precious metals and then talk about production of secondary metals from scrap. Now, again I repeat that precious metals like silver, gold, platinum group metals, all with low affinity for oxygen, are found either in free state or in rare cases, as in the case of silver, as very easily reducible compounds. When we say free state, it does not mean there are chunks of platinum or gold lying around. No, they have to be found amidst rocks, or they are found as some waste that come out of processing of say sulphides, where you remember during electrolytic refining of copper, under the anode there would be slime. That slime contains precious metals. The metals have gone through all the metallurgical process steps without reaction. To start with, they were in elemental form, but mixed with so many other things that you cannot very easily get them. You have all heard about rivers where gold particles are found with the flowing stream, Subarnarekha for example, and there are rivers where even today many people do panning. They take cloth and put it in against the flow of water, wait for hours to see if one or two particles of gold that are coming with the stream will get trapped. But there was a time when gold could be found in plenty in nature. And you have heard stories of plentiful gold in Latin America. You may have heard about Emperor Montezuma, who was captured by the Spanish, and then they said they would release the emperor if his subjects could fill up a room with gold objects. And they were astounded that day after day the subjects came with huge artifacts of gold, and they finally did fill up the room. But that Montezuma was not released is another matter. But Latin America had so much of gold that there were stories of cities which are paved with gold bricks. Then lot of gold was found in America, and there was gold rush in the gold mines, where from the rocks they found huge quantities of gold. Now, India has always been very highly attracted towards gold, and that attraction continues. Every household in India likes to have a private hoard of gold. We did not produce that gold in the country, however, because India used to import gold from all kinds of countries, Middle East, even from Rome, from Tibet, and India today has a huge deposit of gold. Lot of them in temples, in private hands. Some of our temples, like in Tirupati, they are estimated to have some 15 or 20 tons of gold in their vaults. Why were Indians so attracted towards gold? Much more than other people, were the Indians were fond of jewelry for adornment. Their kings and nawabs and emperors loved jewels and gold. So, they kept on collecting gold. So, gold has what we say ornamental value. Now, when I mention this word ornamental value, let me discuss what we mean by the word value. Now, before that, let me quickly go through what is written in this slide. The learning objectives of this course will be production of gold, silver, platinum group metals, production of secondary metals like copper, lead, zinc, aluminum, tin, etc. And if time permits, I will discuss utilization of some metallurgical wastes, which are not which do not have metallic values in elemental form, but they are source of metals. Now, let me go back to this question of what we mean by value. When we talk of a metal as a precious metal, why do we call it precious? The word precious means that it is distinguished by rarity and very high price. Now, is it very highly priced because it is rare? It is not necessarily so. There can be something which is very rare, but it may not be highly valued. This word value can actually have many meanings, and we can think of at least 4 kinds of values: utility value, ornamental value, exchange value, prestige value. Let us see the differences. I need to say this because it has much to do with the valuation of precious metals. Consider a currency note of say rupees 500. Now, the currency note has value in India, Indian currency. Suppose you take it to another country. If you take it to an European country, it has no value there. There is nothing that can be obtained in exchange, unless you go to a designated bank counter where they can exchange that Indian currency note with a local currency note. But suppose you go to just a countryside or go to any country among the population and show them a 500 rupee note or a 1000 rupee note, it does not have any value there, because the value of that piece of paper is a designated exchange value as guaranteed by the Reserve Bank of India, and that exchange value is valid only in India. It has an exchange value elsewhere in those banks where in exchange of that Indian currency they will give you the local currency note. Now, think of India, that piece of paper which says rupees 500 now can fetch you goods worth 500 rupees, because it is a standard the government has set in and the population and by and large accepted. During the time of wars, when things go out of order, many currency have gone completely haywire. Like what was available for 1 rupee, perhaps after a week would have been priced at 100 rupees. This happened during Second World War in many countries. That is why if you go to the currency of Italy, it is always million lira, not 1 lira, 2 lira, it is always in millions, because the inflation devalued the currency so much during Second World War that what was available for tens or hundreds became available only for millions. So, this exchange value is an arbitrary value fixed by the government of India and accepted by the society, and it gives a standard of exchange. Before we had these currencies, things had to be on the form of a barter, that you give me a goat, then I will give you 10 kilos of rice. This kind of bartering even takes place in remote centers of the country even today, in remote rural areas. They may not be using the currency so much, they might actually go for barter. There the goat has an exchange value of this much, or 10 kilos of rice has an exchange value of this. But as of today, what we know is a currency note has a value which is an exchange value. Now, more basic value is what we call utility value, that it has an utility and it is more universal. Like if you have a chair, it has an utility value, people can use it to sit. You take the chair to any part of the world, it has a value called utility value. This value may not be the same everywhere. For example, in our country wood is very expensive. So, wooden furniture costs a lot more than if you go to a country like Canada, where wood may not be so expensive, it may not cost so much. Of course, it could cost more because everything costs more there, that is a different matter. But you understand, there is a basic value called utility value, depending on the utility. So, when it comes to metals and alloys, they all have utility values, because they can be used in various applications. So, it is a commodity with utility value. Incidentally, commodity is something you can buy or sell, that can be traded. Now, all these precious metals are also commodities, but their utility value is not as high as the price indicates. They have a exchange value of a very high order, because it has been fixed like that. They also have two other kinds of values. One is prestige value, because only the rich and the affluent, they can afford gold. Gold, platinum, silver, they are associated with prestige. That prestige is not directly linked to utility, nor linked with exchange. Its value is prestige value. It also has an ornamental value, because it is used in adornment. Just to give an example and close this discussion, suppose you have a painting of M.F. Hussain. Those who do not know the painting may not understand the value of that painting. Again, you go to a remote place somewhere where they have not seen M.F. Hussain's painting. If you ask them how much would you pay for it, people may not like to pay anything for it. Or if somebody likes art, he might say, okay, I will pay you 10 rupees or 20 rupees. But if you tell them it is selling in the international market for crores of rupees, they would not believe it, because the painting is not costing that much because of an utility value, not because of an exchange value. It has a prestige value, because it enhances the prestige of the owner, and it appreciates. There are other reasons why diamonds and paintings they cost so much, because it is a way of the wealthy to keep their wealth at one place. If they buy Hussein's painting now, after 10 years they can sell it for 10 times more. So, in a small space they can keep a lot of wealth. Now, coming back to these precious metals, their price also relates to prestige, relates to tradition, relates to acceptance by population. Gold from time immemorial has been accepted as a standard basis of wealth. The more gold an emperor has, the more respect he commanded. Diamonds, of course, also. Today, every country therefore has to keep a stock of gold in the vaults to establish its financial status, and gold is the international basis of financial exchange. So, gold has an exchange value, gold has a prestige value. It is, the value is much more than what we say an utility value. Its value is fixed on different criteria. Now, I would say the gold is most attractive of all the precious metals. It is best known. All the platinum is more expensive, but gold is most attractive. It is worth being judged not in terms of rarity or usefulness. No, it has ornamental value, it has prestige value, and it has exchange value. You give this much of gold, you can buy a lot of things with that kind of gold. It is a symbol of wealth and power, and this metal is the basis of international monetary transactions. This is not true for platinum or silver, a bit for silver, but not for platinum. It is gold which is the basis. Of course, it has utility, not that it has no utility. It has outstanding ability to keep its shine. This is what attracted mankind to gold, that a piece of gold remains shining forever. It is a symbol of eternity, and when it shines on a body, the body looks so much more handsome and beautiful. As regards its properties, it has an amazing ductility, and a 1 rupee coin can actually be drawn into 1.5 kilometer long wire, and because it has ductility, it can be beaten to the thinnest foils, 0.0000002 centimeter thick. And that is why even today some very expensive sweets or pans can have a gold foil. There are also Ayurvedic medicines covered with gold foil. There is tiniest fraction of gold in that. Had gold not been so ductile, I do not think not many people would have ever been able to afford the Ayurvedic medicine or the pan or the sweet, but it does give a shine, makes it look good. And you have seen the gold foils on so many temples gurudwaras. The golden temple of Amritsar is covered with gold sheet. This sheet is not very thick, because it is beaten into a thin sheet. I do not exactly remember its thickness, but had it not been so ductile, it will be much more difficult to cover the entire Gurudwara with gold sheet. Similarly, the other temple, the temple in Banaras, is also covered with gold sheet. Incidentally, this was donated by none other than Ranjit Singh, the Lion King of Punjab. He had given that gold for covering the Vishwanath temple. It is all because the gold can be beaten to a very thin sheet. But then gold has other uses. It is used in dental alloys, in very special containers, Ayurvedic medicines, in many electronic and other applications. We can have gold for contact, because it will never get oxidized, it will always maintain good metallic contact. These are very special uses, but again the value of gold is not because of its utility, it is because of other reasons. Now, coming to silver, this also has an ornamental value for slightly lower classes. Like amongst us, those who are very rich can afford to have diamonds and gold. Those who are not so very rich very often would settle for silver. Silver also looks good. As a matter of fact, silver has a special appeal because it has the whiteness. Gold usually has the yellowish color, and that whiteness sometimes goes very well with diamonds, it goes with some kind of a jewelry. It can be alloyed with gold. As a matter of fact, all gold has some silver in it. Why it is? I will discuss that later, because different amounts of silver and copper gives better properties to gold in terms of fabrication. They also add different hues. You can have from white to green hue can be imparted to gold by adding silver and copper. So, silver and gold go together, but silver has a utility value. It is a material which has the highest electrical conductivity, highest thermal conductivity. So, silver can find applications in that, but silver has a problem. Silver tends to tarnish with time, tends to lose its shine. So, it needs some maintenance from time to time. Now, because of its properties, silver is used in electroplating, it is used in photography. Silver halide is what was used in photographic plates. It is used in dental alloys, it is used in reflectors, silver solders are there. So, silver has a lot of utility value. Silver and copper additions, as I mentioned a little while ago, harden gold. Pure gold is not good for making ornaments, because it is too soft. So, some impurities in the form of copper and silver, when added to gold, makes gold more useful, so that it can make ornaments. But additions of silver and copper impart a wide variety of colors that range from red through yellow to green, and these colors are very highly valued in jewelry. You will find these kinds of colors in many Rajasthani ornaments, gold ornaments, but there are these colors, and it has come from alloying of copper and silver in different proportions. Now, in nature, wherever there is gold, there is silver. These two go very often, and normally the ratio of gold to silver is 1 to 13. 1 gram of gold, there will be some 13 gram of silver, and these two can be separated. There are very standard methods of separating gold and silver. Now, let us move on to the other precious metals, more expensive, that will be the platinum group of metals. Now, if you see the television, very often they show what is the financial status of the world. Sensex, they will show Nifty, all kinds of things. They always show prices of metals, and to show the health of the economy, they always quote prices of gold and silver. They do not talk about platinum group metals, which are more expensive, because gold is the standard and also silver. And you should see the price, and price of gold and silver are not according to their availability in nature. It's all arbitrarily fixed. Platinum group metals have a utility value. Platinum group metals also have ornamental values, not so much as exchange value. As a matter of fact, if you happen to have something made of platinum, you can be in big trouble, because you cannot sell it anywhere. It does not have value, sale value, whereas if you have gold, you can always sell it, or if you have silver, you can always sell it, of course, at a slightly lower price, because when you buy a gold ornament, it has the price of the metal and also price for the craftsmanship. So, when you take it back to a jeweler, you will buy back the gold, and they would not give you the money you had paid for craftsmanship. So, the price should be some 15 to 20% lower, but the gold metal has a value. Supposing you had bought some gold 10 years or 20 years ago, some ornament, today the value would have appreciated so many times. So, many people like to invest in gold and silver, because the price will appreciate. But if somebody had given you a chunk of platinum, you are in trouble. It cannot be sold. Even the jewelry shops which make platinum jewelry will not buy the platinum from you, because there are some regulations about use of platinum. So, if you have platinum vessels, platinum wares, or platinum thermocouples, platinum rhodium things, it has to only go back to 1 or 2 designated companies which make things out of platinum. So, platinum, rhodium and platinum group metals do not have this easy resale value as gold and silver have, although they are far more expensive. Now, platinum group metals have utility value. They have high temperature melting point, resistance to corrosion and oxidation, and these make the metals suitable for special applications. For example, you can melt salts and slags. In all our laboratory work, if you want to melt glasses, what kind of, you have to go for platinum group of metals. You cannot melt them in gold or silver, because the melting point is too low. You will need temperatures of the order of 1500, 1600, which platinum group metals give us. Of course, pure platinum is soft. So, it has to be alloyed with other metals in the group, like rhodium or other metals. The platinum group metals also have other attractive properties. Some of them are high ductility, low vapor pressure, low coefficient of thermal expansion, high temperature coefficient of electrical resistivity. Now, all these properties are exploited in various applications, and you know that for temperature measurements, platinum, rhodium thermocouples are so very commonly used. They can go to very high temperatures, and they are just the right materials for making thermocouples. So, platinum group of metals have utility value, they also have prestige value. They do not have exchange value for commoners. Maybe at very high levels it can have an exchange value, but for between you and I, between you and me, it would not have an exchange value. Now, let us look at the relative abundance of these precious metals. You will find that their price that are set does not correspond with their availability. Now, the availability shown in a log scale. If copper is available in earth's crust, zinc is quite below that, not so much. Platinum is actually much more in abundance as compared to say gold and silver. It is lot more in abundance. In the log scale you see gold and silver are here, but platinum is here, but still it is much more expensive. Why it is so? Well, there could be many reasons. One reason would have the difficulty of producing that metal. Abundance is not the only criterion for the price of a metal. It depends on how difficult it is to produce that metal. It may be abundant, but it may be very difficult to produce. The extraction process is difficult. So, the extraction process that makes it more costly, and as I said, there are also some arbitrary ways of fixing prices in the case of these metals. So, those are also reasons. So, platinum is comparatively more abundant, then comes ruthenium, osmium, rhodium, palladium, silver and gold are here. So, the point I want to make is, though platinum is much more abundant, it is priced at a higher level. All these are abundance shown compared to zinc taken as a standard as 1.0. Compared to zinc as 1, these are the relative values of the abundance. Now, coming to uses of palladium and platinum, I have already mentioned quite a few things. Let me repeat some of them. Coming to platinum first, platinum is also used in jewelry. Unfortunately, platinum as a metal is not that very attractive. Sometimes it looks almost like aluminum. So, the designer has to depend a great deal on designing the right kind of jewelry, and it is invariably its value is enhanced by combination with diamonds, because diamonds go very well with platinum. So, about 1/3 of it or a little less than that is going into jewelry. It finds lot of application as chemicals and chemical equipment. In catalysis, platinum serves as a very good catalyst in many reactions. We make chemical equipments and of course, glass apparatus. In many glass apparatus, we will have platinum. Electrical contacts, miscellaneous electrical applications, spark plugs, because platinum will not corrode, it has high electrical conductivity. So, these electrical applications are there. Another metal with which we are normally not very familiar, but these metals are also there, precious metals, is palladium, which has dental applications, some applications in jewelry, also like platinum in chemicals as catalyst, in pharmaceutical catalyst, in electrical applications. Platinum, palladium, rhodium, singly or in alloy form, they find various applications. Now, I will quickly go through the various steps in the production of gold, silver and platinum. Again, I will skip many details. I will not go into the details of the processes, they are available in books. Something about gold extraction has been mentioned quite some time ago when we were discussing application of kinetics in understanding extraction processes. That was with reference to cyanidation. I will come to that again. Cyanidation happens to be only one of the several processes for gold extraction. The first process for gold extraction was invented by Egyptians 3000 years ago, if not more. They had found, they were also fond of gold, and they had found particles, small particles of gold embedded in rocks. That is how gold is found very often in land masses, that there are rock surfaces where you see particles shining. Those shining particles are gold particles. How do you take out those tiny particles of gold embedded in huge masses of rocks? Extraction of gold from a mineral is not the topic now. Gold is there as gold in elemental form, but it is embedded in whole lot of rocks which do not interest you. They can be considered gangue. So, we need to have a beneficiation process, some way to separate gold from the rest other things. The Egyptians found a way of removing that gold by a cyanidation process, by a amalgamation process. By the word amalgam, we mean solution of gold in mercury. What they would do, I do not know how they found it, is break the rocks, crush them, grind them into very fine form. You need to have crushing and grinding to release the gold particles which are embedded in rock surface, and then they made a slurry. They put it in a suspension in water, and the slurry was allowed to flow down a slope where they also poured mercury. So, mercury and water slurry, when they came down a slope, the mercury dissolved the gold particles into itself. Now, if gold is brought in contact with mercury, it very readily dissolves and forms an amalgam. It is like a solution of gold in mercury. It is not a compound, it is almost a solution. Now, there were various ways of making the process very efficient, but definitely one needed ground rocks, grinding of rocks for release of gold particles, then a slurry, and then slurry and mercury all will tumble down a slope, and in that process gold would go into the mercury to form an amalgam. And then it was very easy to separate the mercury, because after all the rocks and mercury they will separate very easily. Mercury is very heavy, it will be at the bottom, you just separate out the mercury. Question now comes, how do we get now gold out of the mercury? It was very simple. Mercury has a very low boiling point. You boil, evaporate mercury out, and gold is left behind. Now, Egyptians also came up with a very brilliant method of determining whether the removal of mercury was complete. What they would do, they will weigh, they will heat the amalgam, and after heating for a while they will weigh it, and obviously they will find the weight has gone down because mercury has been distilled off. They will weigh periodically until the weight did not change anymore. Then they knew that the mercury has been evaporated. Now, for weighing they needed very good balances. At that time the Egyptians had invented the beam balance, and they had some very accurate beam balances. Some of them are still there in the museum in Cairo. They can measure to maybe 1/10 of a gram or even to a greater accuracy. So beautifully they were made. So, they will take the amalgam, heat it in a furnace to distill of mercury, cool it, weigh it, repeat the same weighing, and when they found the weight was constant, they knew all the mercury has been distilled off. That was the amalgamation process. Now, this amalgamation process is not practiced any longer, because if you are heating an amalgam and releasing mercury vapor, you are doing something which is very dangerous for human health. The workers at that time perhaps did not know, but if many of them had premature death, it will be from inhalation of mercury vapor. Today perhaps you could do it, taking a lot of precautions, etc., but handling huge amounts of mercury is never recommended as an acceptable thing in today's industry. So, amalgamation process is no longer practiced. The other second method is cyanidation. This I have mentioned earlier, discussing some kinetic principles. In cyanidation, basically the reaction is this, that we dissolve mercury in sodium cyanide solution. Now, there is silver with gold. So, the gold will also undergo the same reaction. I am showing only the anion side, that cyanide anion reacts with gold to take form AuCN2 minus. So, this is taken into solution. Some people write it slightly differently. They said that somewhere a peroxide is formed, that peroxide also takes part in the reaction, and the overall reaction is something like this: gold being taken into solution by cyanide ions, and you have an anion containing gold. Now, this is also not a very safe reaction, because when you are potassium cyanide, of course, is a deadly poison. Sodium cyanide is also a poison. It can also give rise to HCN gas under certain circumstances, which is also a very dangerous gas. So, this process also requires a lot of precaution. Unfortunately, there are not many solvents for gold, because gold is one which does not react with different media. It cannot, it will not be dissolved in, say, sulfuric acid or hydrochloric acid or sodium hydroxide. You cannot do leaching of gold particles. Had that been possible, it will be very simple. Bring crushed rocks in contact with acids or alkalis. There is an acid which can dissolve almost everything, that is aqua regia, but we are not talking about aqua regia. We will talk about aqua regia later. But they have found that cyanides dissolve gold for some reason. So, there is no other leaching reagent today than gold, the cyanide. And once you have this, it is quite easy to recover gold once it has been dissolved by cyanide. Before that, again I will go back to the word of caution I mentioned. NaCN is poisonous. If there is any acid anywhere, then poisonous HCN gas is produced, and this is a dangerous gas. Now, once gold has been taken into cyanide solution, it can be very easy, gold can be easily taken out by cementation. You know about cementation now. If you have a copper sulphate solution, and in that if you put a piece of iron which is more reactive, copper precipitates on the surface of iron. Now, gold is even more noble, it is even lower than copper. So, if you put anything above that is placed above in electrochemical series in contact with cyanide solution, then gold will get precipitated on that metal surface. Now, there are many metals, all the metals are above gold actually in EMF series. So, you have to choose what metal you want to use. Generally, we would like to use something which will not be expensive, which will go into solution, and we should find it easy to take it out of the solution and recover again. That metal very often is zinc dust. Why dust? Because dust will have greater surface area, so reaction will be faster, or it can be a zinc wire which will gradually dissolve in cyanide solution, or we can use aluminum powder also. Once they dissolve, gold is precipitated out. If we are using zinc, then the zinc can again be recovered by, if there is a residual zinc in the gold, because the gold will entrap some zinc, we can recover that by heating. The other way of getting gold out of the cyanide solution will be electrolytic process. We can electrolyze. Another very attractive process is selective absorption of specially prepared carbon powder surface. Gold cyanide, it is not cyanical, it should be D, this C should be D, is absorbed and then released into aqueous phase by heating the carbon powder. So, we can have activated carbon powder thrown into the cyanide solution. It will absorb gold cyanide onto the surface, and later on gold can be released by heating it. So, this is the cyanide route. Previously, I had also talked about the chlorination process. We can actually chlorinate and take out gold as a gold chloride. Now, that could be a very effective way of chemical beneficiation of the rocks and gold mixture. Gold is there in elemental form, but to take it out we can chlorinate and remove gold as a chloride. But generally the technique followed is simply the cyanidation process. In India, we have only one place where we extract gold. You have heard about it, is Kolar gold mines. Now, unfortunately, mining activity has been going on in Kolar for such a long time that they are going deeper and deeper and deeper, several kilometers deep they have gone, digging rocks which contain gold particles. Now, they have gone so deep now, the deeper you go, the more difficult it becomes to continue mining operations, because you are going deeper down. From there all the rocks have to be lifted for processing. Labor has to go down and then go up. All the communications have to be there from the surface. So, the deeper the mine, the more difficult the mining process becomes. The Kolar gold mines have already become very difficult from economic point of view. Also, the gold content in the rocks is also going down. So, I am not sure how long the operations in Kolar gold fields can continue, but we have not been able to find many other areas where we can do gold extraction. Interestingly, a lot of interesting work is going in the bioleaching of gold, which will make things lot more simpler, that instead of very elaborate processing of gold rocks, cyanidation to take gold into solution, there are now bioleaching processes where the bacteria will do the job for us, will bring gold into solution, but I will not discuss that now. I will discuss the conventional method of gold extraction as is followed in coal gold fields. We use the word ore. Here the word ore only means it is the source of gold. It does not mean it contains any mineral of gold. It is rocks which contain gold particles, and those particles are in elemental form. It will need lot of crushing and grinding, because unless we bring it to a very finer particle size, we will not be able to release the gold particles. And please remember, we use the word crushing to bringing down the particle size to some size, and below that we talk about grinding. Basically, both crushing and grinding means size reduction or comminution. Now, in the case of our Kolar goldfield operation, one goes through 3-stage crushing operations of rocks which contain only 5 gram of gold per ton. So, in a ton of rocks, there will be just about 5 grams of gold, but that is good enough for an economic operation. So, it goes through 3-stage grinding, then 3-stage crushing and 2-stage grinding. Why it is 3-stage, why it is 2-stage, we need not discuss. You can never go to a very fine form in one stage, you have to go stage wise. And there are also different stages and different ways, because crushing and grinding needs a lot of energy. So, there are ways of minimizing by having different steps and combining them in different ways. Finally, we go for a gravity concentration using inclined blanket table. Like once you have a fine crushed and ground rocks with gold particles, if we make a slurry and then let it go along a slanted things, gold particles are heavier, so they will segregate. And we use the word concentrate, which has more metallic value, and tailings, which have less metallic value. This concentrate goes for sodium cyanide leaching. Calcium oxide is used for some reason, I am not quite sure now. Then we do filtration, the residue will go into the tailings. We will see what is there in the tailings. From here we will precipitate gold by adding zinc, then there will be leaching step, roasting, smelting. Finally, we can produce a gold bullion 92%, 92.5% gold, 7.5% silver. Now, here the tailings, we are segregating here gold and silver, and there the tailings would go through again sodium cyanide leaching, will precipitate gold by silver, acid leaching, and then there will be left with a bullion again 92.5% gold and silver, which means nothing is allowed to go waste. You go through the concentrate, residue tailings should also be treated same manner, but eventually we do produce gold and silver, mostly gold and little bit of silver. About the rest you can please read up. Essentially what I have said is that although in theory there are different processes for gold extraction, amalgamation process, chlorination, we are still use the conventional cyanidation process, where sodium cyanide is the leaching reagent, a dangerous leaching reagent. So, it has to be used with a lot of precaution. Gold will be dissolved as a cyanide, then it will be cemented out by using zinc or aluminum. Zinc is easier because if zinc is trapped in the gold, which normally it always will be, it can be easily separated by heating. Zinc can be removed by heating, and then there are various steps of which are standard steps for chemical steps to ensure that you get a purer product. Next we will come to silver extraction. Now, you know, silver and gold are always associated with sulfides, because sulfides are very good solvents for precious metals. But in ores of lead, copper and zinc, the sulfide of silver can be present as a mineral called argentite, Ag2S. It is a very weak sulfide, and 75% of total gold output of silver is from refining of base metals, and only about 25% silver ore proper. There are some silver ores, but most of it will come from the slimes that we obtain during electrorefining in the case of base metals. So, I will discuss it in the next lecture. Thank you very much.